Hi everyone, so these are going to be your 1.5 notes looking at probability. So in this section we will focus on calculating the percent of the time an event happens and then interpreting these percents as probabilities. Our first definition is of relative frequency. Frequency is the number of times an event occurs. Relative frequency is the ratio formed when frequency is divided by the total numbers. And that setup is going to be our wanted outcomes. So what we're looking for to happen out of the total outcomes. And another word for relative frequency is also probability. So they are one and the same. Whenever it's asking you to find the relative frequency of something, it's the same as asking you to find the probability. So for example, if 8 customers in a group of 40 used a coupon, then the relative frequency of using a coupon in that group is 8 out of 40, which is also equal to 0.2 as a decimal or 20% as a percent. A relative frequency can be expressed as a fraction, decimal, or percent. For example 1, it says a local high school has 1,280 students. Of these students, 388 are freshmen, 312 are sophomores, 289 are juniors, and 291 are seniors. For the directions, we're going to, for each of the following parts, find the relative frequency as a percent and then round it to the nearest tenth. If it says the nearest tenth, that is going to be to 1 decimal place. So for part A, it says, what is the relative frequency of sophomores at this high school? So remember, we want our wanted outcome for the top over our total outcomes. So that's going to be the sophomores is what we want, and that's going to be out of all the students. So the sophomores, we can see that there are 312, and they tell us, we could add up all of these to see how many total students there are, but they tell us that it's out of 1,280 students. So we're going to go ahead and just divide. When you divide, you get 0.24375. We're going to multiply that by 100 so that it becomes a percent. We get 24.375, and we want to round it to the nearest 1 decimal place. So that's going to be 24.4%. What is the relative frequency of students who are not seniors? So for this one, we want them to be not seniors, and we're going to have them out of all students. So the bottom, that's still easy to find. That was our 1,280. But the top, you can do this one of two ways. You could add up all of the freshmen, sophomores, and juniors together, or you could just take 1,280 minus the amount of seniors that you have. So you could just do 1,280 minus 981. Either way works though. We'll go ahead and just add up all of them that aren't seniors. So that would be 388, 312, and 289. So we get 989 out of the 1,280. We're going to divide, and that will give us 0.77265. Change it to a percent. So 77.265, round it to the nearest 1 decimal place. So we get 77.3%. The last one says, what is the frequency of students who are upperclassmen? So that would be juniors or seniors at this school. So for this one, we want juniors and seniors out of all students. So we can just add up the junior and senior amount. So that'd be 289 and 291, which gives us 580. Divide that, we get 0.4531. Multiply that by 100, we get 45.31%, and round it to the nearest one decimal, so 45.3%. For example 2, a national survey asked how many people were living in the respondent's household. The table below shows the results. Find the relative frequency of households with more than 8 people and interpret it. So for this one, we want more than 8 people. So we're going to not even include 8. We're only going to go to 9 and above. If we look at how many people are at 9 or above, it is 3 plus 1 plus 1, which is a total of 5. To find how many people altogether that we have, to find what it's out of, we would have to find the overall total. So our overall total is, if we add up all of these numbers, we get 2,538. If we divide that, we get 0.00197. As a percent, if we multiply it by 100, this would be 0.197%. And then the last thing is, we want to look at it out of every 1,000 households. So if we're interpreting it and we're looking at it out of every 1,000, the trick to this is to take this this as a decimal. So take this as a decimal and multiply it by 1,000. So if it said out of every 10,000 households, we'd multiply it by 10,000. But this is just out of every 1,000 households. So if we do that, we get 1.97, and we want to round it to the nearest whole number, so that will be 2. So it's 2 out of every 1,000 households. Okay, for the next part, we're going to be looking at experimental probability. Experimental probability is the same as probability, so same meaning as that, and it's also interchangeable. You find it the same way as doing your relative frequency. So all 3 of those words are just pretty much interchangeable. Probability tells us the likelihood or chance of something happening. Relative frequencies that tell us what percent of the time something did happen can also be considered experimental probabilities. These percents can be used to say what percent of the time we expect something to happen in the future based on actual data. So experimental probability is based on something actually being actionable, it actually happening. For example, a recent survey showed that 40% of Americans approve of the job the president is doing. In other words, we would expect 40 out of every 100, or 4 out of every 10, or 2 out of every 5 Americans to approve of the job the president is doing. You could interpret this as an experimental probability and say that if you randomly pick an American, you would expect to get someone who favors the president about 40% of the time. All right, for example 3, if there were 4 million births in a particular country and 2,247 sets of naturally occurring triplets, what is the experimental probability of having triplets naturally. Express your answer as a decimal and then provide an interpretation. 4 million is going to be our total possible outcomes. Our number of births or pregnancies, we can even think of it, would be our 2,247. So we're just going to divide that, and we're going to round it to 6 decimal places. So this will be with 6 decimal places. So we get 0.000562. If we change it to a percent, we can multiply by 100. So this would be 0.0562%. And then for the last part, it wants us to interpret it out of every 10,000 births. So we're going to take this, multiply it out of 10,000. So we get 5.62 and round that to the nearest whole number. So that would be 6. So it's 6 out of every 10,000 births. Okay, for example 4, it says in a particular city, 12 in 2.7 million people have been struck by lightning. What is the experimental probability of being struck by lightning in this city? So we're going to take 12 out of, and if you're curious about how to write 2.7 million, you're going to have the 2 in the millions place, and then the 7 will follow, and then you're just going to make the rest zeros so that you have it representing 2.7 million. So we're going to divide. When we divide, we get 0.0000 and then 4 repeating. We want it as a percent, so we're going to multiply by 100. So we get 0.00. And whoops, I accidentally made a mistake here. There should be 5 zeros after the decimal. And so we get 0.000 for repeating percent. And if I want to round that to 4 decimal places, that's going to be 0.0004%. It seems a little bit funky, but you just do it the same way that you did all the other ones. For example 5, it says in a particular city, 86 in 2.5 million people have been struck by lightning. What is the experimental probability of not being struck by lightning in this city? So to find how many are not struck by lightning, we're going to take how many are. So that would be 2.5 million, and we're going to subtract the 86. So we get 2,499,914, and we're going to have that out of the 2.5 million. So we're going to divide. We get 0.9999656. We want to change it to a percent, so we're going to multiply by 100. So we get 99.99656%. And this one also asks to round to 4 decimal places. So we get 99.9966%. For example 6, it says the following table shows the number of survey respondents who completed each level of education. Change each frequency to a relative frequency as a percent. Complete the total column as well, and you're going to round each percent to 1 decimal place. Okay, so remember that we are doing our wanted out of our total. So when I want to find the relative frequency of those that were less than high school, I'm going to take 330 and I'm going to divide that by my total. So I actually need to, before I end up filling in any of the boxes in the second line, I need to find what my overall total is. So for this, you would just add up all of these numbers. We get 2,538. So I'm going to take 330 out of that. We're going to divide. We get 0.1300. I'm going to multiply it by 100. So we get 13.0%. And that's what I'm going to put for that one. Okay, I'm going to just do one more of these. So let's do the bachelor's degree. This one would be 472 out of the 2,538. If we divide, we get 0.1859. Change it to a percent, so 18.59%, which would round to 18.6%. All right, I'm just going to give you guys the other ones. So this one would be 50.0%. And if it's 0.0, you can just do it as like 50% or 13% here. This one would be 7.3%. And this one would be 11.1%. Now your total, I want you guys to make sure that you are remembering that it's all of it out of all of it. So you're not going to add up these because remember that these were rounded. So you want to think of it as finding the overall total, which would give us 1, multiply it by 100, we get 100%. So this one will always be 100%, even if they add up to something a little bit differently just because they were rounded. Example 7. Recently, a poll was conducted to try to understand consumer coffee habits. Complete the following table. So we have different age groups, and we have 2 different categories. They either drink at least 1 cup per day, or they do not drink at least 1 cup per day of coffee. And then we have the overall total. When we look at this, we have this column missing. So in order to find these values, we know the total of that age group, so I can just subtract how many do drink at least 1 cup of coffee per day. So for that value, it would be 744 minus 357 to give us the 387. To find this one, we're going to do the same thing, 519 minus 342, so we get 177, and the same idea for the last one. So 266 minus 196, we get 70. For your overall totals, you're going to just add up that column. So for this column, we would add up 357, 342, and 196, get 895. Add up this column, same way, so we get 634, and same thing with the last one. We get 1,529. Okay, now we're going to go ahead and answer some follow-up questions. For part A, it says, find the experimental probability that someone in each age category drinks at least 1 cup of coffee per day. And then it has a follow-up question of which is the highest age, which age group is the highest. For part A, you are going to find the experimental probability that someone in each age category drinks at least 1 cup of coffee per day. So you are going to do it for each of the 3 age groups. So you're going to do it for age groups 18 to 44. You're going to do it for the age group 45 to 64. And you're going to do it for the 65 and up age group as well. So when we look at each of these age groups and we're trying to find the probability of them drinking at least 1 cup per day, we want to only look at that specific age group. So for instance, the age group of 18 to 44, I'm only going to use these values. I'm not going to use any of the other totals. So to do that, I'm going to have the amount that do drink at least 1 cup per day in that age group out of the total for that age group. I'm going to divide. I get 0.4798 multiplied by 100, 47.98. And if I round to the nearest, on this one, we're going to round to the nearest whole percent. That would be 48%. For the age group 45 to 64, we have 342 out of their total 519. We get 0.6589. So we get closest to 66% for that age group. And then 65 and up, it is 196 out of the 266. So that will be closest to 74%. And so when we look at which age group is the highest, this one has the highest probability. For part B, it says find the experimental probability that someone over the age of 65 does not drink at least 1 cup of coffee per day. So if we do it, there's 2 ways of doing this. I know we'll actually look at both. One way would be to take the amount that do not, so 70 out of the 266. We get 0.263 or 26%. But the faster way of doing it, if we already have what percentage do drink at least 1 cup per day, we can just subtract the amount that do from 100 to get the same answer, the amount that don't. And then lastly, find the overall probability that someone 18 years and up, and all of them in the survey are 18 and up, drink at least 1 cup of coffee per day. So we want those that are, yes, they drink at least 1 cup of coffee per day out of the total. So this is 895 total that drink at least 1 cup per day out of the overall total. So we get 0.585 multiplied by 100, we get 58.5%. So that will round to 59%. Okay. The last definition that we have is theoretical probabilities. Tell us what should happen based on theory and not experimental results. We'll discuss these further in cycle 2. For example, if we flip a coin, our theoretical probability of heads is 50%. Okay, this wraps up section 1.5. If you have any questions, please feel free to reach out.